Good evening, sir. Myself Harshita, bearing a roll number 2440580 from Tripoli branch. So, in DCMT subject, my topic is about phasor diagrams. So, coming to the phasor, my topic is about phasor diagrams of actual transformer with resistance and reactive drops, considering with resistance and reactive drops in transformer. So next, coming to the transformer. What is meant by transformer? A transformer is a static piece of equipment used either for rising or lowering the voltage of an AC supply with a corresponding decrease or increase in current, or otherwise a transformer is a static device that transfers the electric power from one electrical circuit to another electrical circuit without any change in frequency or power, but with the change in voltage or current by using step down transformer or step up transformer. In step up transformer, the voltage should be increased. This can be used in distribution stations, whereas in case of step up transformer, step down transformer, to decrease the voltage, this can be used in substations, and the step up transformers will be used in transmission lines like generating stations, like etc. Next, coming to the practical transformer. This is the transformer picture. So these are electrical lines coming into the transformer. This is the outgoing lines to the load. So primary side, this is primary winding. In secondary side, represent secondary winding. This is the next transformer oil represent inside of the transformer. These are the bushings. Next, this is the practical transformer picture. Next, coming to the transformer with resistance and reactance, leakage reactance. So there are two requirements in that. So first one is it must supply the no load current I naught to meet the iron losses in the transformer and to provide flux. To provide flux in the core, we use magnetizing component of current Im. To meet the iron losses in the transformer, we can use IW, working component of the current. So we already know that one. It must supply current I2 dash to counteract the demagnetizing effect of secondary current I2. So the magnitude of I2 dash will be such that, so here primary power is equal to secondary power. N1 in place of I1 we can substitute I2 dash. Next is equals to N2 I2. So I2 dash is equals to N2 by N1 I2. We know that N1 by 2 is the transformation ratio K. K into I2. This is the equivalent circuit diagram. Next, coming to the phasor diagram of actual transformer with resistance and reactive drops in inductive load. In inductive load, we can take an x-axis and apply. So we can already know that one. In the inductive load, current lags the voltage by some angle. In pure inductive, it is 90 degrees, but in case of normal inductive nature, so current lags the voltage by some angle. So here clearly shows that phi 2 angle. So this is V2, which lags the voltage by I2, which lags the voltage by V2. So this angle is pi 2 between V2 and I2. So I2 R2 exactly parallel to this I2. So this is exactly parallel to the I2 R2. Next I2 X2 exactly 90 degrees to the this one I2 R2. Next, so this sum of this R2 and X2 will use the Z2. So this is I2 Z2. This is secondary side. So coming to the primary side, same. I2 dash is exactly opposite to the I2. So this is exactly opposite to the I2. This is I2 dash. This is X0, I0 plus IW. So the sum of these two, I2 dash and I0, will give us I1. So next, I1 R1 exactly parallel to this I1. So this is I1 R1. Next I1 X1 exactly perpendicular to this one, I1 R1. So the sum of these two is Z1, I1 Z1. So we'll give V1. So angle between V and I1, V1 and I1 will give pi 1. So here load power factor cos pi 2. So in secondary side we can calculate the load. So that's why load power factor is cos pi 2. Primary power factor cos pi 1. Input power to the transformer V1 I1 cos pi 1. Output power V2 I2 cos pi 2. This is in case of inductive load. Next, coming to the phasor diagram of actual transformer with resistance and reactive drops in capacitor load. We know that in capacitor load, current leads the voltage by angle. So this is V2, this is I2, which leads the voltage by some angle pi 2. So this is pi 2. Next, this is I2 R2 exactly parallel to this one. This is I2 R2 and I2 X2 is perpendicular to this one. Sum of these two is Z2, which gives I2 Z2. Next, this is the secondary side. Coming to the primary side, similarly. This is I2. This is exactly opposite to the I2 dash. Exactly opposite to the I2 is I2 dash. So I0 sum of I0 and I2 will give the I1. This is the I1 value. So next I1 R1 exactly parallel to the I1. This is I1 R1 exactly parallel to this one. Next, this perpendicular to the I1 x1 is perpendicular to the I1 r1. So the sum of these two is z1, I1 z1. Here cannot represent. Next, 0 to v1. So angle between v1 and I1 will give pi 1, power factor pi 1. So same in capacitor load, same the current leads the voltage by some angle. The figure shows clearly. Next, coming to the phasor diagram of actual transformer with resistance and reactive drops in resistive loads. So in resistive load, we can already know that voltage and current are in phase. Thus the angle pi 2 is equal to 0, cos pi 2 is equal to cos 0 is equals to 1. So same, the here V2, I2 are in phase within the load. So this is the I2 R2. I2 R2 is exactly parallel to this I2. Next, perpendicular to this one. X2 is perpendicular to this one. Sum of this R2 X2 is gives Z2. This is secondary side. Coming to the primary side, I2 exactly opposite to the I2 dash. Next, I1. This is I0. Sum of these two is I1. So I1 R1 exactly parallel to this one. This is X1 perpendicular one. This is V1. So angle between V1 and pi 1 will give pi. Angle between V1 and I1 will give pi 1. So similarly, same. These are the same happens. So these are the phasor diagrams of under inductive load, under capacitive load, under resistive load, with considering of resistance and reactance drop also. So next, coming to this is the equivalent circuit parameters. So compared to E1, V1 is greater than V1. So in case of primary, in case of secondary, E2 will be greater compared to this V2. So this is because of the drop. So these are the equations of the primary side. These are the equations of the secondary side. Refer to the secondary side. So thus my presentation. This is my overall presentation, sir. So thank you for giving this opportunity. Thank you, sir.